Hello, welcome. As you can see, we're going to be talking about Gauss-Jordan elimination, and specifically, we're going to be solving 3x3 systems, which are basically equations of planes. And if we have two planes that intersect in space, most of you at this time should know that intersection is a line. And now, if you can visualize running another plane through that line, when a line passes through a plane, it just creates a point. So the most typical result is a point. However, we could have parallel planes. We could have three planes that don't all intersect. We may have three planes that all intersect in a line. So we're going to give all three examples and just go through the Gauss-Jordan process as I do it. Hope you're open-minded to this, because I might present something a little bit different than you've seen in the past. So here we have an example of three planes, what people might call third dimension linear equations, because there aren't any exponents, but they're actually planes. So what we're going to do is we're going to go ahead and set this up into a matrix of coefficients. And the first thing I do is I look for what my very best x value would be and see if I can reduce any equations. For instance, this first equation. If the z term was 6z, I would divide that entire equation by 2. But there are no equations here that we can reduce. We may see that soon. And general terms, I would take the lowest coefficient on x, which is 2, and make that be my first term in my matrix. So I'm going to set this up as 2, 4, 1, -4, 2, -4, 6, just our coefficients, 13, 4, -2, 1, 6. And I refer to this guy as our hired hitman, and his job is just to eliminate the other values in its column. Now, I know a lot of people do Gauss-Jordan at this point, and they would divide the first row by 2, saying that you always need a value of 1 for that hired hitman position. I don't do that. What ends up happening if you do that, you have to work with fractions down the road, and if I'm doing this by hand, I think I would rather not work with fractions. Okay, so I look at my hired hitman, who has to eliminate the 2 in the row beneath it, and I say, well, the least common multiple of those is 2, so that's really a nice situation. So I notate this, and you'll see what I'm doing here. I notate this I'm going to multiply row 1 just by 1, by -1, because I need a -2 to eliminate a 2, and I add it into the second row. So as I move on to my next matrix, the hitman row does not change, but the next row, and I call this, and it's kind of a visual, and I call this touch, and where I would take my pencil and I would touch it right here on this 2, touch it on the -1 over here. I'd go touch, 2 times -1 is 2, add into 2, -2, touch, -2 and 2 is 0. And then I continue that with the 4. 4 and -1, -4 and -4, -8. 1 times -1, -1, added to 6, 5, and -4 and -1 multiplied together, +4, added to 13, 17. So my hired hitman has done its job on row 2, but now I have to eliminate this 4 using the hired hitman. So 2 and 4, least common multiple is 4. I need a 4. I've got one in the bottom row. I need a -4. I'm going to multiply the top row by -2 to turn my hitman into -4. So then, touch. 2 times -2, -4, plus 4, 0. 4, guess I can underline it, times -2, -8, and -2, -10. 1 times -2, -2 and 1, -1. And -4 times -2, 8, plus 6, 14. Okay, so there's our first step. Our first hitman has done his job. Now, what I do next is I call that house cleaning, and I look at any row and see if I can reduce it. There is no row that's reducible by an integer value. The next thing I would do is, if my position, my -8, who's going to be my next hitman, if that was a 0, I would switch row 2 and 3. I can't have a hitman be a 0. Another option would be if the -10 in row 3 was a 1, or a -1. I might switch the rows to have my hitman be a smaller number, but I'm just going to continue on with -8 being my hitman, who is in charge of wiping out 4 and the -10. Okay, so we just go right down the diagonal with our hitmen. Okay, so -8 and 4 would match up at 8. I need a +8 and I need a -8. I've got a -8, so I'm going to create a +8 in the first row by multiplying by 2. I'm going to make this value +8. So next matrix, touch, touch. Oh, in fact, I'm going to multiply by 2, and I'm going to add this row up into it. It's always the hitman going to the hit ease neighborhood. This -8 is going to go up and pay a visit to row 1. Okay, so if I touch, touch, now I'm taking this 2 times this 2, 4, adding in this 0. The 0 comes and visits it, and we end up with a 4. Then I take the 4 here times our 2. That's 8. Add on the -8, 0. 1 times 2, 2. 5 comes and pays a visit. Turns that into a 7. Excuse me. And -4 times 2, -8. 17 pays a visit to -8, and we get 9. Hitman row does not change. 0, -8, 5, 17. And then, a little tougher here. This is the price to pay if you don't want to work with fractions. -8 and needs to whack -10. Their least common multiple is 40, which means I need a +40 and a -40. I'm going to multiply row 2 to get to 40. I'm going to multiply it by -5 to give me a +40. And if that -8 becomes a +40, the -10 must become a -40. I'm going to multiply by 4. And then I'm going to let my hitman's row pay a visit to the -10's neighborhood. Okay? So as we go through this, it gets a little easier as we go after this point, because I get 0 times -5, 0, plus touch, 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 0 times 4, 0, 0 plus 0, 0. Then I get the -8 times -5, 40, the -10 times 4, -40. Those cancel, they better, that's why we're doing it. At this point, we might want to use a little scratch paper. My next step, I'm going to take 5 times -5, -25, and I'm going to add on to that -1 times 4, -4, and this value becomes -29. Okay, and finally, again, here's where the scratch paper might come in handy. I have to take 17 times -5, -85, and add on to that 14 times 4, 56, and that becomes conveniently -29. So that's the price to pay where you have to multiply both rows. You wouldn't have to do that if you reduced everything, the hitmen, to 1, but you would have to work with fractions. I think it's well worth going ahead and not working with fractions. All right, so let's take a look at our house cleaning step now. After each step, I look for house cleaning, and I notice the third row can be divided by either -29 or 29. I'm going to divide it by -29. So at this point, I might just notate over here, divide by -29, and maybe just go in with pencil and erase that, but I'm going to go ahead and create a new matrix here. So I'm just going to repeat the first row, repeat the second row, and then divide the third row by -29. And what we've just learned is that the value of z, because this is our z column, this bottom row, the statement there is 0x plus 0y plus 1z equals 1. Z is 1. In our ordered triple, our final value, oh, maybe I won't have room there. I'm going to put it down below. Our final value in our ordered triple is 1. Okay, next step, new hitman. We just go right down the diagonal. Here he is, and that's a pretty convenient hitman right there. So I need 1 to whack 7 and 5. So 1 and 7 match up at 7. I need a 7. I need a -7. I'm going to multiply the last row by -7 and have him go pay a visit to the first row. So we get 0 and 4. 0 and 4, 4. We get 0 and 0, 0. We never lose a 0 we work for. We get 1 times negative 7 and 7, 0. That's our purpose. And we get 1 times negative 7 plus 9, 2. I need to multiply row 3 by negative 5 and pay a visit to row 2. So 0 times negative 5, 0 and 0. Never lose a 0 we worked for. 0 times negative 5, 0, added into negative 8. 1 times negative 5, negative 5 added into 5, 0. That's why we're doing it. And 1 times negative 5, added into 17, 12. And our last step in this, to get this in what's called row-reduced echelon form, which, by the way, your graphing calculators do very well for you in matrix mode. You can look into that. Our last step is to, I'm just going to divide this row by 4, and I get 1, 0, 0, 2/4, or 1/2. Divide this row by negative 8, and I get 0, 1, 0, 12 on negative 8, or negative 3/2, and 0, 0, 1, 1. That is what's called row-reduced echelon form, and very, very quick, slick, and very process-driven way. I also have a video out there at, if you go to purpleshirtednerd.com in Chapter 7, I have a video on creating an Excel program that will do this for you, if you have some interest. Okay, so there's our case of 3 planes that intersect at a point. That is the most common occurrence when we have 3 planes. There are a couple other possibilities, however, and we're going to explore those. Okay, I'm going to go a little quicker this time. Things I note when I'm looking at these 3 equations in problem 21, none of those reduce, but I'm going to prefer to put equation 1 first. I love the 1 coefficient in front of x. So I get a 1, 1, negative 2, 3. And then it doesn't matter to me after that. 3, negative 2, 4, 1, first equation. Last equation, 2, negative 3, 6, 8. So I am going to speed up just a little bit on this. If you want a slower pace, you can go back and review the first. But I'm going to use 1 to whack the 3 and the 2 beneath it. So 1 and 3 match up at 3. I need a 3. Got it. Need a negative 3. So I'm going to multiply first row by negative 3, pay a visit to the second row. Hired hitman row does not change. Understand, I'm going to take each of these values times the negative 3 and pay a visit to row 2. So 1 times negative 3, and 3, 0. 1 times negative 3, and negative 2, negative 5. Negative 2 times negative 3, 6, and 4. And 3 times negative 3, negative 9, and 1. Okay. Then I'm going to multiply first row, you guessed it, by negative 2, pay a visit to the bottom row, and I get 1 times negative 2, and 2, 0. 1 times negative 2, and negative 3, negative 5. Negative 2 times negative 2, 4, and 6, 10. And 3 times negative 2, negative 6, and 8, 2. And you might notice we got something kind of suspicious going on here in rows 2 and 3, but I'm just going to continue on as if I was not a thinking human. I was just a calculating robot here. I want to now use negative 5 to whack the 1 above it and the negative 5 below it. So I'm going to go ahead and multiply row 1 by 5 to turn this 1 into a 5. I need a 5, I need a negative 5, and come pay a visit. So I get in row 1, 1 times 5, 5, plus 0, 5. I get 5 plus negative 5, 0. That's why we're doing it. I get negative 10 plus 10. That's a bonus 0. I get 15 plus negative 8. I get 7. In row 2, I stay the same. 0. Hitman row does not change. Negative 5, 10, negative 8. Row Row 2, to get the -5 to whack the -5 below, I need a 5 and I need a -5. I'm going to multiply row 2 by -1 and go visit row 3. So that would be 0 and 0. Never lose a 0 we worked for. -5 times -1, 5, and -5, 0. That was our purpose. 10 times -1, -10, and 10. That's 0. That's a bonus 0. -8 times -1, 8, and 2, 10. So let's consider this bottom row right now. What does this mean? That means in equation land, 0x plus 0y plus 0z equals 10. And that is a dead giveaway at this point. We can't have values for x, y, z to make that statement true. This is really, if you had a lot of these problems to do, you wouldn't be sorry if this happened quite a bit, because our work is now done. We have no solution. There's nothing that's going to make that occur. We have either parallel planes or 3 planes that are all, kind of imagine this. You have a wall on the left of the room, a wall that joins that in a corner, and then a diagonal wall joining the two ends of the walls. Maybe all 3 walls go straight up in the air, but there is not a common intersection. Okay, let's go on and look at the third case where all planes intersect in a line. Okay, in this example, I do note I've got a 1 in my very first position, so I'm going to, no doubt about it, I'm going to use that first equation first. I've got a 1, a 2, a -7, a -4. Second equation, 2, 1, 1, 13. But the third equation, I'm going to make my computation easier if I notice that that reduces by 3. So I get a 1, a 3, a -12, and a -11. And I'm good to go. And I need to start writing a little bit smaller. We're going to take a little more room on this problem. Okay, step 1. I would like 1 to pay a visit to the 2 and 1 beneath it. But if 1's going to visit 2, better go there in the form of -2. I'm going to multiply row number 1 by -2, add it into the second row. First row does not change. Second row becomes 1 times -2, -2 and 2, 0. 2 times -2, -4, and 1, -3. -7 times -2, 14 and 1, 15. -4 times -2, 8 and 13, 21. Okay. Next step, I want to multiply row, I've got a 1 that needs to whack a 1, so one of those has to be -1. I'm going to go ahead and multiply first row by -1, send it down. So I get -1 and -1 times -1, -1 and 1, 0. That's why we're doing it. 2 times -1, -2, and 3, 1. -7 times -1, 7, and -12, 5. And -4 times -1, 4, and -11, -7. And so now I notice row 2, I can house clean that guy. So again, I might just do something like this, divide -3 or 3, either one, and then erase if I was using pencil. But I'm just going to go ahead and rewrite this. 1, 2, -7, -4, 0. Divide this row by -3, I get 1. Oh, you know what? Do I have a mistake here? Let's take a look at when I sent this guy down to this guy's neighborhood. I had a 7 and a -12. That is a -5. Apologize for that. You probably caught that. Row 2, when I'm dividing by -3, I get 0, I get 1, I get -5, and I get -7. And row 3, I have 0, 1, -5, -7. Now I'm awfully suspicious that we've got a special case when I look at row 2 and 3, but I'm just going to continue on with our process at this point. New hitman right here. That's going to need to be multiplied by -2 and sent up, and by -1 and sent down. So let's see where that takes us. I get 0 times -2, 0 and 1. I get -2 and 2, 0. That's what we're doing this for. I get +10 and -7, 3. I get negative 7 times negative 2, 14, and negative 4, 10. Hitman row stays the same, 0, 1, negative 5, negative 7. And to eliminate the third row, to eliminate this guy right here, I'm multiplying second row by 0, 0 times, or by negative 1. 0 times negative 1, 0 and 0. 1 times negative 1, negative 1 and 1, 0. That's our purpose. Negative 5 times negative 1, positive 5, and negative 5, 0. And negative 7 times negative 1, positive 7, and negative 7, 0. And you say, oh, no solution. Well, wait a minute. This is the equation 0x plus 0y plus 0z equals 0. We get lots of values that work for x, y, and z here. So what we have is a common intersection. We have all three planes are intersecting in a line, and here's the way we're going to handle that. And this might be new if you've seen Gauss-Jordan before, so if you feel like you knew everything going into this, maybe you're going to catch something new here. At this point, we're going to say that the value of z in our ordered triple is a. Just some arbitrary value a. And if that is the case, what is this equation? This equation is 1x plus 3z equals 10, or 1x plus 3z, if z is a, we get this equals 10. So x is 10 minus 3a. I'll show you what we're going to do with this, or what this is doing for us. Seems kind of weird. Why do we even bother having variables in our answer? I think I'm going to explain that in a manner you can understand shortly. Okay, let's look at equation 2. What is that equation? That is 1y minus 5z's, but if z is a, I'm going to put a in there, equals negative 7, or y equals add 5a, joins a minus 7. So what does this thing mean? This is the answer we have in the back of our book, but I want it to have some meaning for us. I'm going to clear off the black equation work down below just to give myself a little bit more room. I think it's good to know what that means. That is, that is what I refer to as our ordered triple generator. That is a point generator for us. So if you were asked, okay, if you were told this problem has a lot of different answers, give me 3 of those. Give me 3 ordered triples, you could do this. Well, if one of the ordered triples, a is 0, and I put 0 right here, I get 5 times 0, 0 minus 7, negative 7. If I put 0 right here, I get 10 minus 3 times 0, 10 minus 0, 10. That ordered triple, 10 to the right, down 7, and out 0, is on the intersection of the planes. And I can pick any value I want for a. What if I put in 1? I get 5 times 1, 5, minus 7, negative 2. I get 10 minus 3 times 1, 10 minus 3, 7. And what if I put in 2? I get 5 times 2, 10 minus 7, 3. I get 10 minus 3 times 2, 10 minus 6, 4. So that generates all of the ordered triples. It is not really correct to say that when this happens, that it's all solutions. It's most definitely not all ordered triples. I would suggest that 11, negative 7, 0 is not on the intersection. But this will generate some for us. So hope that's helpful for you. Stay tuned. Again, you might be interested in at purpleshirtednerd.com. In Chapter 7, Section 3, there is I take you in Microsoft Excel through a process that will instantly find solutions to 3x3 systems such as we're looking at here. It will not tell you the ordered triples, but it will go through the Gauss-Jordan process. And it's probably something that you can put together right as you go on the video in maybe 15, 20 minutes. So thank you very much. Good luck and stay tuned.